Welcome. Today we're going to explore different strategies to prove that lines are parallel. Our methods that we're going to be using are the same postulate and theorems that we've been talking about for the last couple of days. Basically, we're going to take what we know if we have parallel lines, that certain angles have to be congruent or certain angles have to be supplementary, and we're going to reverse the order of that information around. So we're going to be using converses of the postulates and theorems, which is where you swap the hypothesis and conclusion with each other. So last week we talked about how there is the same side interior angles postulate, which said if we have parallel lines, then we know that same side interior angles are supplementary. Well, today we're going to be reversing that information. So if we have two lines, we don't know they're parallel or not, that are cut by a transversal, and a pair of same side interior angles are supplementary, then it turns out that the lines have to be parallel. And for these other two converses, we're going to reverse the sentences in the same way. So rather than starting out knowing that lines are parallel, that's what we're going to try to figure out as a result. So if we have two lines cut by a transversal and a pair of alternate interior angles are congruent, then we know the lines have to be parallel. And the same idea, if we have two lines cut by a transversal and a pair of corresponding angles are congruent, then again, we know the lines are parallel. So if we can recognize these different special pairs of angles, and if we can tell that the same side interior angles are supplementary or alternate interior or corresponding angles are congruent, then that gives us enough information to guarantee that lines have to be parallel. So let's practice applying that information for these next three diagrams. So down here, we're asked to find the value of x that makes lines M and N parallel to each other. So if we're looking here, if I want M and N to be parallel, I need to do something with this 120 degree angle and this angle that's 3x. Well, if I look at where these angles are located, I can see they are both between the pair or the lines that we want to make parallel, and they're both to the left of this transversal. So they are inside the parallel lines. They're on the same side of the transversal as each other. So these would be classified as same side interior angles, or SS int angles for short. And we know that if the same side interior angles are supplementary, then the lines have to be parallel. So we can write an equation where these angles are supplementary. So to do that, we would add them up and set them equal to 180 degrees. And if we solve this, subtract 120 from both sides, we'll get 60 equals 3x, divide by 3, and we'll get x has to equal 20 for those. If we look at the next diagram, we're told information about this pair of angles here. And this pair of angles are, again, between the lines that we want to make parallel. They are on different sides of the transversal. One is to the right, one is to the left. So these would be considered alternate interior angles. And according to our converse, if alternate interior angles are congruent, then we know the lines have to be parallel. So we can set an equation where we set 135 equal to 2x plus 15. Subtract the 15. Divide both sides by 2. And we'll get x equals 60. So if x is 60, then this angle down here will also be 135 degrees. So the alternate interior angles will be congruent, which will guarantee that these lines M and N have to be parallel to each other. Now for this last example over here, it's a little trickier because these angles would be classified as alternate exterior angles, but we don't have a theorem talking about alternate exterior angles. So we have to get a little creative. So what other pairs of angles could we work with? Well, looking at this diagram, I can see that I have some pairs of vertical angles happening, and we know vertical angles have to be congruent. So I'm going to go ahead and mark this angle here has to be the same as whatever x is. This angle up here has to be this 180 minus x. So we actually have a couple options here. Based on this pair of angles right here, these would be considered corresponding angles. Or if you have the 180 minus x up here, these angles right here would be considered alternate interior angles. So whichever pair you choose, you would want to pick the appropriate name to go with it. So let's focus on these two angles here. These would be considered corresponding angles since they're in roughly the same location at each intersection. They're both below the transversal and they're both to the right of each of the parallel lines. So they're in roughly the same locations, so they are considered corresponding. So if our corresponding angles are congruent, that's how we know the lines have to be parallel. So we can set x equal to 180 minus x, and if we solve this out, we'll get 2x equals 180, and divide both sides by 2. We'll get that if x is 90 degrees, then that's enough to guarantee that the lines N and M have to be parallel to each other. So this is one way you might be asked to demonstrate knowledge of how to ensure that lines are parallel or how to identify that lines are parallel. Other times you might be given more abstract drawings like what we see down below. So down here, we have several different scenarios. So we're not told specific angle measures, we're just told that they are parallel to each other. So again, we're trying to figure out if we have parallel lines. So I want to look at the angle measures or the angles that are identified and decide if they fit into any of these situations. If they meet any of these situations, that's the only way we can tell that we have parallel lines. So if I'm looking here, the marked angles are both to the right of the potentially parallel lines, and they're both above this transversal R. So they're in roughly the same places. So these are corresponding angles. So since the corresponding angles are congruent to each other by the converse of corresponding angles theorem, since we have two lines cut by a transversal, a pair of corresponding angles that are congruent, we can guarantee that the lines are parallel. So we can say yes, M is parallel to line N by, this is the converse of the corresponding angles theorem. I'll let you work on the next couple on your own. So you may want to pause this video now so you have a chance to work through several of these before we talk through it together. So moving on, we can see, let's look at this next row down here. So looking at this diagram here, we do not have a special name for this pair of angles. So we want to figure out what other angles are also congruent, because maybe we have a special name for one of those pairs. So we can go ahead and identify the vertical angles that are also congruent. And if I'm looking at this diagram, I notice that these two angles here would be considered same side interior angles. Those are same side interior angles. So we have same side interior angles that are congruent. Is that enough to ensure that the lines are parallel? Well, let's check up here. So the converse of the same side interior angles postulate says if two lines are cut by a transversal and a pair of same side interior angles are supplementary, then the lines are parallel. The problem is the angles have to be supplementary. And if we look at this diagram, we're not told that they're supplementary. We're only told that they're congruent. So unfortunately, we don't have enough information to ensure that the lines are parallel. So we would say, no, we don't have enough info because we don't know if the same side interior angles are supplementary. All that we know is that they are congruent to each other, which isn't enough information for us, unfortunately. This next diagram also does not give us enough information because what we have here are a pair of vertical angles. And vertical angles are always going to be congruent whether there's parallel lines or not. So no, because vertical angles are always congruent. Even if no parallel lines exist. You can check the rest of the answers to the other 3 diagrams with the answer key that's posted in Google Classroom. At this point, let's talk about the proofs on the back. So first of all, I want to apologize. There's a slight typo in the copies I made. So let's go ahead and fix those real quick. So for this first proof, it's asking us to prove that lines G and H are parallel. If you notice, there are no lines G and H in the diagram. This should be prove that lines M and N are parallel to each other. Also, we can go ahead and fix in the second proof. The given information, it should be that lines A and B are parallel to each other, not lines A and D. We can see that they intersect down here, so it's not possible for them to be parallel. Once we've made those 2 corrections, we should be good to progress. So in a proof, our first step is always going to be whatever our given information is. So we want to number our steps. So we have step 1, so that'll be for the statement. That's the given information about angle 1 and angle 3. And the step 1 reason is going to be given. Now, once we know this information, I always recommend we mark it on the diagrams. So we'll have angle 1 and angle 3 are congruent to each other. We don't know how many steps this is going to take yet, so we can just fill out the numbers for step 2. So at this point, we don't know that there's any parallel lines, so we can't use any theorems that require parallel lines yet. Looking at this diagram, we can see that we do have a hidden piece of information. We have a pair of vertical angles. So angles 1 and 2 are vertical angles with each other. So we know that angle 1 and angle 2 have to be congruent. The reason is not definition of vertical angles. The definition of vertical angles just describes where they're located. It doesn't say anything about their angle measures. But there is a theorem that says vertical angles are congruent. It's a short sentence, and that is what we're going to be using a lot. We won't be using the definition of vertical angles. We will be using the sentence, vertical angles are congruent. And now that we've proven that, we can go ahead and mark that in our diagram. So at this point, I can see that angles 2 and 3 are also going to be congruent because they both have the one tick mark or the one arc symbol. So I can say angles 2 are congruent to angle 3. The reason I can't say because they both have one arc, but because angle 1 is congruent to angle 3 and angle 1 is congruent to angle 2, we could use either the substitution property or transitive property to justify that angle 2 and 3 are congruent. At this point, we've shown that we have a whole bunch of congruent angles, and we have enough information to justify that we have parallel lines. So if we're looking at this, angles 2 and 3 would be considered corresponding angles because they're both above what will be parallel lines, and they're both to the right of this transversal. So they're in corresponding locations. since the corresponding angles are congruent, we know that we have to have parallel lines. So this means that lines M and N have to be parallel to each other. So the reason that we would provide is the converse of the corresponding angles theorem. So we showed that we had several different sets of congruent angles until we were able to figure out a pair of corresponding angles that were congruent. Once we knew that, then we could show that we had parallel lines. For the second proof, we're going to follow a similar process. So our first statement will just be to copy whatever the given information is. So line A is parallel to line B, again, fixing that typo. And we know that angle 2 is congruent to angle 10. So I'm going to go ahead and mark that in my diagram. So angle 2 up here is congruent to angle 10. The reason is that it was given to us. So the next step, step 2 in this proof, well, looking at this diagram, I don't see any labeled angles that are vertical, so I probably won't be using that in this proof. But we are told that we have some parallel lines. So if I have parallel lines, that means I have some things, some special pairs of angles. So if I'm looking between these parallel lines, lines A and B, lines A and B are cut by two different transversals. There's transversal C and transversal D. So if I'm looking, when it's cut by those transversals, line C helps to create angles 2 and 6. And if I'm looking at where they're located, they're both above the parallel lines and they're both to the right of this transversal. That means angles 2 and 6 are going to be corresponding angles. And because they are corresponding angles formed by parallel lines and a transversal, we know that they have to be congruent to each other. So we can say angle 2 is congruent to angle 6. And the reason is the original corresponding angles theorem, the one that we had talked about in the last lesson. It says if we have two parallel lines cut by a transversal, then corresponding angles will be congruent. So that's how we were able to tell that angles 2 and 6 are congruent to each other. At this point, we have three angles that are all congruent to each other. So we can take the information that angles 2 and 10 are congruent and angles 2 and 6 are congruent to say that angles 6 and 10 are congruent. And again, this would be an excellent use of the transitive property, where we're linking things together and we're basically taking out the shared element in the middle. So we're focusing on the beginning and the ending thing of that long list of things that are all congruent. So we have angle 6 and angle 10. Now, we're trying to prove that lines C and D are parallel to each other. So if we have lines C and D shown here, lines C and D have to be cut by a transversal, either transversal A or transversal B. And based on the angles formed by that, we would then be able to prove that they are parallel. Well, if we're looking at angle 6 and 10 relative to lines C and D, we can see that angle 6 and 10 are both on the right side of lines C and D, and they're both above line B, the transversal. So that means angle 6 and 10 are corresponding angles. So since they are corresponding angles that we've shown are congruent, that's enough to guarantee that lines C and D are going to be parallel to each other. So we can say that line C is parallel to line D, and the reason will be the converse of the corresponding angles theorem. So we were able to show that since 6 and 10 are corresponding angles formed by line C and D when it's intersected by line B, that means that lines C and D have to be parallel to each other. Go ahead and take a moment and try to complete this last proof at the bottom on your own. And when you're ready, check your answers with the answer key.